important. Thank you. We thought it was important to carry on, to stay on track, and that's what we're doing. So on to happier and more optimistic courses. And I'm very happy to introduce Henning Rodell, who's been working with Stanford on the Moon for a good 10 years. As a background, he got his PhD in civil engineering in 2011 from Stanford, has developed and experimented with various building materials for the moon. And Henning will be introducing our three speakers and then turning the program over to Loretta Hidalgo-Whitesides to moderate the panel discussion. I might say before, I don't know if Loretta is on yet, but she spoke 3 years ago at Stanford Moon. Thank you, Loretta, and I wanted to commend you again for your challenge, your pioneering presentation on First Woman on the Moon 3 years ago. It was one of the very first presentations on that subject that we were aware of. And now look at how far we've come in 3 years, where the cutting edge of the American space and moon program is to send the first woman soon to the South Pole of the moon. So with that, thank you all for taking time out and keeping on track with Stanford and Stanford on the Moon. And Henning, I don't know if I have to push any buttons or mute myself, but you've got the comm. Thank you.
Thank you, Steve, and thank you for reiterating the mission and the purpose of Stanford on the Moon. I too hope that one day either our Stanford material or work that's being done in the civil engineering program can contribute to that first overseas program facility. So without further ado, I'm happy to kick off this program. And just a little bit of housekeeping. Everyone should be muted, and feel free, if you have a question during any of the talks, to please include it in the chat window, and we'll facilitate the questions after each of the speakers. And so I'd like to introduce our first speaker, who is joining us by video recording. And this is astronaut Tammy Jernigan. She joined us last year, and I believe the year before that at the annual SOM reunion event. And so Tammy is an astrophysicist and the second of Stanford's 10 women astronauts to go into space after Sally Ride. Tammy studied physics at Stanford and then studied astronomy at the University of California, Berkeley, and was awarded a PhD in 1988 in space physics and astronomy from Rice University. Tammy has completed 5 space shuttle program missions, logging about 63 days in space. Jernigan left NASA in 2001 to work at Lawrence Livermore National Laboratory. Today, Tammy is having an active role in the education of her 2 sons, one who's now a freshman at Cal Poly, and the second is a freshman in high school. Throughout her career, Tammy has received many awards, including the NASA Distinguished Service Medal and the NASA Outstanding Leadership Medal. So I'm going to share my screen and share a video that she sent to us. Our agenda for the day.
Henning, if I just could add that Tammy had hoped to be with us, and the scheduling of the Cal Poly freshman orientation was changed many times, and that's where she is now.
Thank you for that note. Yeah. So without further ado, here is her talk, Learning to Adapt.
Hello. Today I was asked to share with you some of my experiences in education during my time at Stanford and as an astronaut, and to discuss ways in which astronaut training has evolved to meet the demands of building and operating an International Space Station, as well as returning humans back to the moon and eventually onto Mars. I'll also discuss how this pandemic has placed new demands on educational institutions, similar to those NASA has historically learned to navigate. Lastly, I will comment on the opportunities that might be realized as a result of the investments in new educational strategies being made in response to the pandemic. I received an excellent education as a physics major at Stanford, and like many of you, I learned through self-study, classroom lectures and labs, and by spending long hours alongside my peers studying and cranking out problem sets in the physics library. I did not take any online courses, and there was no virtual training except for an occasional educational video or perhaps a computer simulation. My laboratory work was done in small groups, in person, with no masks, face shields, or social distancing. I attended scientific conferences in person and thrived on the interactions with members of the scientific community. When I came to NASA, I learned about the space shuttle systems and payloads, and eventually the International Space Station, or ISS, utilizing the same strategies as in college, but with added components of training through extended use of mock-ups, simulators, and virtual reality sessions. Also, as astronauts, we learned to work remotely with mission control and with fellow astronauts outside the space shuttle or space station during their spacewalks. NASA has always relied heavily on simulators for astronaut training, since even before the days of the Apollo program. Here is a photo from 1968 of Neil Armstrong training in the Lunar Excursion Module Simulator. We learned to successfully land the LEM on the moon. As NASA began to construct the ISS, virtual learning became even more critical because as ISS grew, astronauts needed to prepare for upcoming space flights by training on complicated systems and payloads that were already in space. This video clip was taken during STS-96, the first docking mission of the shuttle to the International Space Station. Fellow astronaut and Stanford alum Dr. Ellen Ochoa is operating the robot arm with me attached during an 8-hour spacewalk. Our crew relied heavily on training, not only using physical mock-ups and simulators, but also virtual reality, since the components of the ISS with which we interacted were already in space during our training. Also, virtual reality was the only environment available to Earth to replicate dynamics of the robot arm in space with a crew member attached. Learning in a virtual reality environment can prove more realistic and cost-effective. In addition, some training is literally impossible to accomplish on Earth other than in virtual reality. This next video clip was taken during STS-92, a shuttle docking mission to the ISS, where a rescue device called SAFER was tested. It is essentially a jet-powered backpack. Here, my husband and fellow Stanford alum, Jeff Weissoff, is flying the SAFER device where he trained almost exclusively in virtual reality. Today's astronauts, like Nicole Mann, prepare for ambitious Artemis program, where NASA aspires to land the first woman and next man on the moon by 2024. This is an artist's concept of Gateway, an outpost intended to orbit the moon and facilitate human return to the lunar surface and provide a staging platform for deep space exploration. Astronauts will need to learn to operate in a challenging environment far from home and maintain proficiency over the course of a long journey. Fortunately, NASA is an organization accustomed to educating in such a distanced virtual environment. The pandemic associated with COVID-19 has created an extremely challenging environment for many, including those in the educational community. From elementary schools to universities, educators are challenged with providing high-quality education at a time when the ability to deliver content in person is severely restricted. Like NASA, schools and universities must find a way to effectively educate while managing safety risks. My experience with my own sons, a 9th grader and a college freshman, have shown me that secondary schools and universities are working tirelessly to innovate and make difficult decisions regarding new educational models. While NASA integrated distance learning as a necessary component of meeting mission requirements, many academic institutions had little warning of what might be required of them as the pandemic spread quickly throughout the world. However, I am confident that just as NASA delivered excellent training to astronauts embarking on ambitious space missions, educational institutions will continue to devise new strategies to ensure students of all ages receive the education they deserve. Here we have a recent photo of an in-person lab at one California university where students use physical distancing and wear masks and face shields to maintain safety while still gaining valuable hands-on experience. This is not so unlike astronauts training that involve wearing spacesuits and helmets during numerous training exercises. Hopefully, in the not too distant futures, restrictions imposed by the pandemic will be significantly relaxed, and investments in the new educational capabilities being made today will provide greater flexibility for effective learning. Ideally, more students will have increased opportunity for study abroad, internships, and/or meeting family obligations without disrupting their educational progress, as courses are optimized to be delivered both in person and in a virtual environment. NASA's experience training astronauts during quarantine and while in space make them uniquely equipped to navigate the restrictions imposed by this pandemic. Educational institutions are likewise learning how to operate effectively in this new environment and will emerge more resilient and capable as a result. Thank you.
Right. So that was a wonderful video discussing the struggles of learning and how we can overcome it with technology, some of which was pioneered at NASA. So continuing our program, we have a wonderful talk by Grant Anderson of Paragon Space Development. And Grant is a member of the Stanford on the Moon Advisory Committee. He co-founded Paragon Space Development in 1993. Since then, he's led Paragon in the development and qualification of experimental flight hardware for 5 shuttle flights, 2 Mir missions, Russian Progress, and the first commercial payload on the International Space Station. Grant holds several patents, and he and Paragon have received many honors awards, the most recent of which was the 2020 Innovation Leader of the Year Award from the Arizona Technology Council. So Grant, I'll invite you to unmute yourself and share your screen. And audience members, please feel free to type your questions in the chat box, and we'll have a little discussion at the end of his talk.
Oh, okay. I'm frankly, I don't have anything to share at this point. I'm a believer that well, let's put it this way. I'm not a PowerPoint fan. In fact, I was talking to somebody at NASA one time, and they said, "What would you do if you were named the chief engineer for NASA?" And I said, "Ban PowerPoint below management level." I'm sure Nicole would probably put out a cheer there if she was allowed to. And although I do use PowerPoint fairly obviously in my position, and I'm giving presentations that are not engineering presentations. But what I wanted to do is allow for the imagination of this group of people. One thing talking about current and former current and former Stanford students is there's a lot going on in their brains, and so I think making a description, I'd love you guys to have in your own mind here what's going on. We are going back to the moon, and I remember when I heard about the passing of Neil Armstrong, I was actually sitting in church, and I put out a comment on social media that says the saddest part about this is that Neil never got to see us back on the moon. And it was rather funny. The first person to, I think, like or whatever the social media I was on was my mom, who is now 90 years old. And at that time was about, I don't know, 85. But we are going back, and we're going back to stay. We're going back and being sustainable. I was just on a telecon with Kathy Ludens yesterday, which is the new head of human spaceflight, who replaced a longtime member named Gerst. And Gerstenmaier, his name, Bill Gerstenmaier. And I want you to think for a second. I want you to envision for a bit here what it's going to be like. When Apollo landed on the moon in 1969, 600 million people were, there's a little noise somewhere. Somebody has no. I unmuted myself. Is that okay, Henning? Okay. I'm sorry. I must be getting some feedback somewhere. And I'll just keep. Are you guys hearing me fine? Are you guys hearing me fine? For some reason, I'm hearing a delayed feedback from my.
Yeah, Steve, do you mind muting yourself? I'm having trouble.
Sure. Just having a little trouble with the.
Okay, sorry about that. Back to where I was. In Apollo. Let me see if I can. Sorry, I'm having an audio issue. Steve, you mute yourself?
Yeah, I need to mute it.
Okay. Where is?
Henning, is there a way to fix that?
I'm clicking vigorously.
Tell you what I'll do is I'll just turn down my mic, so if anybody wanting to ask a question, just wave your hands wildly, but that will get rid of the feedback there. Okay, so try this one more time. Have anybody else had this problem? I can't wait till we get back. Or meeting each other. So
I'm trying to see this thing. It's going to be like this.
that's one thing. But the other is that there were only 400 million TVs in the whole world at the time. So you think about that, and there was only 3.5 billion people. So somewhere upwards of 1/6 of the population of the world was watching that event. I believe that landing on the moon again, in whether it's 2024, 2025, I believe we can make 2024. It's a definite reach, but it's doable. I believe we're going to have the same enthusiasm because it's an inspiration. If anybody has seen my TED Talk on this, hopefully you're not much of a repeat, but you really understand that humans live vicariously through achievement of other humans. When Nicole goes flying up on the ST-100, by the way, Nicole, system will be keeping your humidity at the right temperature. I mean, the right level, right relative humidity. We will be going with her. Humans are, we think, unique in that aspect. We can live vicariously through other people's achievements and goals. That's why we watch the Olympics. That's why we watch large sporting events, is because we feel viscerally what we can do as humans. People often ask me, what's the first words you want to hear the next person land on the moon say? And I always say, well, I want her to say, and I start off like that. Or if you first people to land on the moon, what do I want to hear them say? I say, this is one small step for a woman. I really want to hear that, Nicole. So I'm expecting that to be in your speech when you land on Mars. Okay. Anyway, and this group here with Stanford going to the moon, what we want to do is whether it's some of this group here or it's other people, that we're supporting that whole idea. If you go look at the space.com from yesterday, I wrote an editorial about why space travel is on the ballot. this time. I'm not endorsing any candidate, but really we should be asking our leaders from here on out, what is your space policy and where is it? And what is it going to do for us? Because we want to make sure that we don't lose this opportunity, that I think if we lose it, it's going to be the last opportunity in my generation, at least, to go to the moon. So I do want to put out a pitch there to really support the space program, be asking the people that you know and the people you can influence to support the program. I wasn't actually told how much time I have. So Henning, can I do a check-in with you so I don't overstep my bounds and otherwise
You're doing you're doing just fine. We haven't had any questions from the audience.
And sorry, wait, let me get my speaker back up here.
Okay.
Okay, sorry about that, Hank.
You're doing just fine. You've got another, I would say, 7 minutes for your talk.
I'm not going to go much too longer than that, other than to get down to the personal. I started Paragon Space Development Corporation 27 years ago, sorry, skipped a half a decade. And the reason I do that is we do life support in extreme environments. We keep people alive. Astronauts are the one thing we keep, main thing at about 70% of our business, but we also do other extreme environments on Earth. And people often ask me, why do you do this? Why did you ever get into this? I must say that if I were to build a satellite, to me, a satellite is a robot in a really cool place and maybe do some really cool things, but otherwise it's still just a robot. You could also be designing robots on a factory floor that have a big cage around them that nobody can touch. The one thing I really love about doing human spaceflight and life support is that we are designing around humans. Humans are extremely difficult to design around. I often give a talk, and I know Loretta has seen it, where I put up a picture of the iconic Da Vinci Veritas Man, and I apologize for the gender specificity there. And I usually say, is this the payload in the human space flight? And a lot of people raise their hand and say, yes. I say, no, it's not. I draw a life support system around them. You will never, ever launch a human into space without a life support mission with them. Even I know how much Nicole loves flying. I think even she would object to being put on a rocket without a life support system. But personally, it's also just that challenge of dealing with humans. And I know we're going to talk about this in the panel a little bit later, and I'd encourage people to ask questions about the human dynamic side of it. A lot of people get very built into the mechanics, especially with a lot of engineers of how you do things. But in reality, it's the human interaction with machines and how they interact with each other that makes spaceflight both interesting and difficult. One thing that's very interesting, NASA, before the shuttle Mir missions, roughly in the mid-1990s, if you ask them what were the top 50 problems for going to Mars, human psychology didn't even make it on the list. After the Mir missions, it went to number 5 on the list. It's that interactions that are very, very interesting. And again, if you go look at my TED Talk, the one thing I say is that I think the number one criteria for choosing an astronaut should be emotional intelligence. That everything else stems from that, definitely you need those skills, especially piloting skills. Nicole, I keep calling you out here, but also the decision skills and stuff like that. But ultimately, especially in long duration space flight, if you're not thinking about the emotional intelligence and how an astronaut interacts with another astronaut, you're going to have difficulties in your mission. So that's all I really want to say, other than you can follow Paragon, what we do. Maybe some of you don't know, we do, like I said, life support in extreme environments. We are working the moon lander on the Dianetics program, which will be the winning team to build the moon lander, which then Nicole will be flying in. And I could say we're also on some other both government and private space programs that I'm not allowed to talk about because of NDAs, but Paragon's goal in life is that the people going up into space look up and see a plaque that says "My Life Support" by Paragon, and they know they're in the best hands possible. That's where we want to be. So, Henning, I'm going to give it back to you and leave enough time for the panel, because I think that's going to be where everybody gets their questions answered.
Fantastic. Thank you, Grant. If anyone has any questions, feel free again to type them into the chat. You'll have another opportunity to hear from Grant later on our panel discussion. So with that, jokes aside, I'd like to introduce our next speaker. It's with great pleasure that I introduce astronaut Nicole Mann. Nicole is an American test pilot and is one of Stanford's 10 women astronauts. She studied mechanical engineering at the U.S. Naval Academy and then commissioned in the U.S. Marine Corps and attended Stanford University, where she received a Master of Science degree in mechanical engineering. In mechanical engineering, specializing in fluid mechanics in 2001. Mann completed astronaut training in 2015 and was assigned in August of 2018 to the Boeing CFT mission, the first crewed test flight of the Boeing CST-100 Starliner. Very exciting. Nicole's awards include 2 Air Medals, 2 Navy and Marine Corps Commendation Medals, and 2 Navy and Marine Corps Achievement Medals. Nicole now works for NASA in Houston, Texas, where she's training for a possible future mission to the moon during the NASA Artemis project. So without further ado, Nicole, the stage is yours.
All right, thank you very much. It's great to be here. Grant, I'd like to thank you for 2 things. One is the humidity control system on Starliner, very important to us. And 2 is kind of like a future thanks for when you cancel a PowerPoint. That's gonna dramatically improve my life. But until you take over and capable of doing that, I have a PowerPoint presentation to share with you. But it's mainly pictures, and I really am excited to show you a lot of the cool things that are happening with the Artemis program and with our efforts in going to the moon and how far along we've actually are coming. So if somebody would let me know if you are seeing my screen.
Fully and clearly.
All right, awesome. So just a quick little bit of background on me. After graduating from Stanford, I went off to the basic school, which is basic marine training. And then I went to a flight school and I learned to fly the F-18 Charlie, which is the Hornet. I flew 2 deployments on the USS Enterprise, supporting operations in Iraq and Afghanistan. And, it was really that time flying Hornets that I started getting interested in space and interested in test flight. I really enjoy flying Hornets operationally, but I missed, the engineering side of things. And so that led me to test pilot school, which was a year-long program and then 3 years of developmental flight tests, which was amazing opportunity to then be able to employ my engineering background and experience coupled with my military pilot experience to help develop some new aircraft, new systems, and new interfaces in the cockpit. It was during that time that NASA announced that they were selecting a new astronaut class. And of course, I was incredibly interested, but thought it was a crazy long shot, but never sell yourself short. So I put my name in the hat. The application process is about 1.5 years long. So after a series of visits and interviews, fortunately, I had the privilege of being selected in 2013. So here's our astronaut class. We were 4 men and 4 women that were selected in 2013. And 6 are military, 2 are civilians, 2 are jet pilots, and the rest come from varying different backgrounds. All hard sciences, though. So you have a physician, an engineer, electrical engineer, a test pilot, or not test pilot, excuse me, but a flight test engineer, and also a helicopter pilot. So a little mix of everybody in the class. It was great to meet everybody with all their different experiences to come together to now train. And you do that for the first 2 years as an astronaut candidate. So they affectionately call you an ASCAN for those first 2 years. And it's just like starting over. You're at the bottom of the totem pole and you go through your initial training. After those 2 years, you graduate and you are an astronaut and you're eligible for your first flight assignment. So when we first came down in 2013, my son was 1.5 years old. So there's a little picture of him giving me a kiss there. And now he's 8 years old. That's our family. We had a chance to go to Zion last year. So it's definitely, a career and an adventure that involves the entire family. So I am now scheduled to fly as the pilot aboard Starliner. Starliner is built by the Boeing company. It's part of the Commercial Crew program that NASA has partnered with Boeing and SpaceX in order to provide transportation of astronauts to the International Space Station. So Starliner is at Kennedy Space Center. We had an uncrewed test flight in December of 2019. Starliner will launch aboard an Atlas rocket built by ULA. And it's a vertical stack, so you can see in the left picture there, there's Starliner rolling out to the rocket, and they're going to stack it inside the vertical integration facility. And then they'll roll it out to the launch pad. The picture on the right there is the uncrewed flight that was stacked and ready for launch. So this will be our ride to the International Space Station. And, you know, this will be the first flight of the spacecraft with crew on board. So we'll spend a couple days in orbit just checking out all those ECLSS systems and all the life support systems that are so critical and important to keeping humans safe and alive in the spacecraft. And then we'll dock with the space station for up to a 6-month-long mission. Well, we'll get a chance to conduct some of the amazing science and research on board the station, and hopefully get a chance to do some robotics as well as some spacewalks while on board. Starliner will stay docked to the space station for the duration of our mission, and when we're complete, we'll get back into Starliner and go through some test procedures and demonstrations on the way home back to Earth for a safe return in the desert of the United States. So you guys, I know, are familiar with Space Station, and we still are flying with the Russians. We launched Kate Rubins just a couple days ago on a Soyuz spacecraft, and they're docked to the International Space Station. Chris Cassidy is up there right now as well, and he'll return in just over a week on a Soyuz spacecraft. But we're also looking at these two companies, SpaceX and Boeing. And those are providing now the transportation of astronauts to low Earth orbit. And it's different than the partnerships we've had in the past where we just subcontract to another company to build a spacecraft. In these instances, we contracted the actual mission itself. And so we are turning over, NASA is turning over the transportation of astronauts to low Earth orbit to these two commercial companies. And of course, that allows NASA to then turn our focus on to the moon. And that's what we're really here to talk about today. So I'd like to share with you just a 1-minute video on this effort.
50 years ago, we went to the moon. We called it Apollo. What many people don't know is that Apollo had a twin.
She was a woman named Artemis, goddess of the moon.
We are returning to the moon.
As a new generation of explorers, this time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
Earth-changing science.
and that the challenges ahead will inspire generations.
This is our manifest.
For all who wonder if we could return.
For all who dreamed of pressing beyond.
This is your calling. We go for all of America.
We go. We go as the Artemis generation.
We go.
So Artemis is the name of this effort where we will send the first woman and the next man to walk on the moon by 2024 and have a sustained presence on the moon by 2028. Those are our goals. Just a little bit of the background on where this came from and where this direction is headed. It started with a space policy directive to send us to the moon and then to Mars. And it's this stepping stone process of going to the moon first to develop the technology, to develop the operational concepts that we need in order to then take our next steps to Mars. And it's different than when we went in Apollo because this time we're going to stay. And so it's the sustained, reliable presence on the moon that's our mission. And the timeline has been set with the Space Council that we will do this by 2024. And we're well along the way. And so this is some of the latest updates I have for you. Of course, why go to the moon? I don't need to talk to this audience about that. We're definitely, I know you're all versed in why we would go to the moon. And a couple things that we'll really touch on today, though, is how that proven technology and capabilities will then further our efforts to Mars. obviously, as we operate in low Earth orbit, we are pretty close to Earth. I mean, we're only 250 miles above the Earth's surface. And if something happened to the International Space Station, or if there was a medical emergency with an astronaut, they could jump in their spacecraft, which is still attached, and be on Earth in about 3 hours. So we have continuous comm coverage with Mission Control. So we are really working hand in hand with the folks in Mission Control on Earth in order to conduct the missions. You take that out to the lunar environment, and now we're looking at, at least 3 days before we're able to return home. And then on the Mars mission at 9 months. So as Grant talked about a little bit, it's so important for these environmental control systems to keep everybody safe, and also for the crew to be able to work together in these confined quarters for such an extended period of time. Additionally, you notice that the velocities coming back from the lunar surface and from Mars are a lot higher than low Earth orbit. So when we come back from the International Space Station, we enter the atmosphere at about Mach 25. And you can see a lunar return is going to be higher than that. So from a technology perspective, that the uncrewed flights we have to the moon, we will focus on a lot the return trajectory, as well as the heat shield system that protects us upon reentry. So it starts with Orion. Orion is our spacecraft that will take us to the moon. It's a NASA program. The crew module is subcontracted out to Lockheed Martin, and the service module to the European Space Agency. Of course, there's a lot of other international partners that build, and companies within the United States that build parts and components of it. But Orion, the crew module, is a similar concept to Starliner and Apollo, all modern spacecraft now, where you have a crew module which is attached to the service module. It's about 50% bigger than Apollo. We'll have the launch abort system on top, which will fire the abort motor in the case that something goes wrong with the rocket, and it will pull the crew module away from a exploding rocket or a rocket that had issues. And then the parachute system will open up and bring the astronauts safely into the water. Just a slide to show how really international this effort is. All these countries have been involved in building the service module, and the service module for the Artemis 1 mission is already complete. In fact, I was at KC just a couple months ago, and it was really cool to see Artemis 1. It's already crew modules stacked on board the service module. In fact, just this week, they installed some of the solar arrays on the service module. So you can see that no longer is this just a concept or a dream or an idea. We have space hardware. We have a lot of the testing complete, and we're really getting ready to go. In fact, this is the Artemis 2 crew module. You can see the structure's already built, and they're already installing a lot of the subsystem components. Of course, another important piece of getting us to the moon is the rocket, and that's the Space Launch System. So SLS is built, and we have the solid rocket boosters are Northrop Grumman, and the core stage is Boeing. We have the ICPS, which is the interim cryogenic propulsion stage. That's built by Boeing and ULA, and that's going to give us the additional thrust that we need to raise our orbit around Earth before doing translunar injection. And I'll show you what that mission profile will look like. But you see then we have some adapter panels, obviously the service module, and then the crew module is the tiny piece there at the top, which is the launch abort system. So I always enjoy looking at a picture like this. It just illustrates how much power and how much effort is needed from so many different people and companies and countries in order to get that tiny crew module to the moon. This SLS that I just showed you, that's block 1. And so you're looking at around 60 or 26 metric tons for a payload to the moon. And that's just the beginning. There'll be a crewed vehicle as well as a cargo vehicle. And we'll talk a little bit about how that cargo will meet the astronauts there in cislunar space. But there are modular and upgrade capabilities for the Block 1 Bravo as well as the Block 2 that will increase our capabilities in payload. That allows us to bring more science, more supplies to cislunar orbit and to the surface of the moon for these missions. So this is the core stage that was completed at Michoud, and you can see by the scale of the people there, it's just massive hardware, and the techniques they use to make these huge core stage are just impressive. If you ever have a chance to visit one of these large manufacturing facilities, there's been a lot of testing that's going on, thanks to the core stage. The structural test articles that were built not only to go through, the vibration and the loads, but also to help with some of the ground operations at Kennedy Space Center and how to transport such equipment and stack it. And so a lot of these testings have already been complete by the exploration ground systems, which are at Kennedy Space Center. And here's one of the structural test articles. It arrives by barge to the vehicle assembly building there in the back. Many of you probably recognize that. That's where we vertically integrated Apollo and Shuttle, and we'll do the same for SLS and Orion. So via barge, then they take the core stage and transport it over to the vehicle assembly building for stacking with the boosters, and then the rest of the payloads on top, as well as the crew module. Back last summer, we had a huge milestone, successful testing of the Ascent abort system. So the launch abort system that's on top of that spacecraft was a successful test where it fired the abort engine and can carry the capsule away from an exploding rocket. And this is just an example of all the small testings that are done, or I say small, but it's just each piece and component is tested on its own before we do the full integrated test in space, all the way up until the landing and recovery. And NASA's working with the Navy in order to recover Orion, which will land in the water. And an amphibious ship will then hook up lines to Orion and stabilization systems and pull the capsule into the well deck of the amphibious ship. And that's how we'll recover the crew module and the crew in Orion. So big picture, what this mission is going to look like is you have Artemis 1 that's planned to launch next year in 21. That'll be an uncrewed mission. I'll give you a couple details on that mission profile here in a second. Then Artemis 2, that will be the first crewed flight to go around the moon. And so that's the first flight where we check out all of those life support systems, and we will send the crew in a free return trajectory around the moon. And they'll do a lot of manual piloting, checking out of all the backup and the manual systems to make sure that spacecraft is ready for Artemis 3. And Artemis 3 will be where we land humans on the moon. Now, we also have to talk about the lander as well as the gateway. And so the interesting thing with this program is that the landing on the moon is not necessarily linked to gateway. We have that flexibility. So when we send the lander into orbit around the moon, Orion will have the capability to dock with lander and then go down to the surface of the moon independent of gateway. Of course, that's just the first step. The further development will be Orion docking with gateway and then using that lander system to send humans down to the surface of the moon, to potentially send other rovers or scientific payloads down to the moon as well. So here's a little artist depiction of what the Artemis 1 mission will look like. So we'll do one lap around the Earth, and then we'll do the TLI, which is translunar injection, outside of the Van Allen radiation belts, and it'll take us about 4 days to get to the moon. After we separate from the launch vehicle, on the way we'll actually deploy a series of about 13 payloads, which are small CubeSats. So we'll be conducting some scientific experiments along the way. The spacecraft will actually fly 40,000 miles beyond the moon. So that's further than we've ever gone during an Apollo mission. And the spacecraft will spend about 6 days in the vicinity of the moon before embarking on its 4-day trip back to Earth. So that's the uncrewed test flight. We are testing everything on that mission. As I spoke, there's a lot of the independent testing that's already been completed, but this will be the first full-blown integrated test. So not only the ground operations and the launch vehicle operations, so the folks that will be controlling all these operations be tested, but we'll also be looking at the deep space navigation, testing our communication satellites, and then, of course, the heat shield upon re-entry and the recovery with the Navy off the coast, off the west coast of the United States. Artemis 2 mission is going to look a little bit different, and that's because we have humans on board. So you can see, obviously, we're launching from the Cape still, and then we will go into orbit around Earth, initially in that low Earth orbit, but then we'll use that ICPS to raise our apogee into a highly elliptical orbit around the Earth. And that will last about 42 hours for that second highly elliptical orbit. The purpose of that is to test out all these life support systems. Should something not function properly or something goes wrong, we still have the capability to return to Earth prior to doing the TLI burn on our way to the moon. Additionally, we're going to look at some of the manual capabilities of the spacecraft. So we'll actually separate from ICPS, do some manual flying, and then rejoin again together. And so we'll be able to test out the manual flying and docking of the systems before we actually find ourselves in cislunar space performing those operations. And that's similar to the buildup that we had with Gemini in the Apollo program, where we checked out the systems in low Earth orbit before we're headed out to the moon. So then we'll do the translunar injection, and this will be a free return trajectory, doing the lunar flyby, again, about 4 days out to the moon, and then 4 days back, where we'll recover again off the coast of the United States. So just a couple pictures here of the lunar architecture. Of course, we have the human landing system. That's a huge component to reaching our goal of 2024 of landing on the moon. And as I mentioned, it's decoupled from the Gateway. And so right now there are 3 companies, Dynetics, SpaceX, and the national team, that are competing for this contract or developing a demonstration type of landers. And it's really exciting because NASA's involved with these companies, and we get to follow along the way, and we get to do a lot of the evaluations with them and work together side by side with these companies in order to determine the best way to live on the lunar surface for that first Artemis 3 mission, as well as developing these systems. Of course, that's the bigger piece of Gateway. Gateway is the long-term sustainable solution. You can see in this picture on the right side, lander is there docked to Gateway. There is a habitat where the astronauts will live on board, a power propulsion element that will provide not only power for Gateway, but could also the propulsion needed in order to change the orbit of Gateway based on our future missions and landing areas on the moon. So an astronaut could stay on board Gateway for maybe a month or 2 months, and from there execute missions down to the moon until we can establish our moon base in order to sustain month-long or longer operations on the surface of the moon. And of course, there's a lot of information out there. NASA's doing a much better job in this environment of social media and trying to get this information out to the young generation, out to folks, so that they understand and engaged how important these efforts are. And that is my quick overview of where we're at with Artemis and how exciting this mission is.
Fantastic. What a fantastic presentation, Nicole. Thank you so much for sharing that update. We have a few minutes, about 5 minutes for questions, or if folks prefer, we can jump into the panel discussion. So the floor is open if anyone wants to type in their question into the chat box. Bird. So Bruce McIntosh asks, I'm curious about the current expectations for Gateway. Bruce, do you have more on that question? Is it likely to be able to, for example, service and assemble satellites or carry a telescope? What sort of applications does Gateway serve in addition to Waypoint to the lunar surface?
Of course, so another big component of Gateway is we'll be able to conduct some of those Mars simulations. while on board Gateway. And so you may have an astronaut live on Gateway, a crew of astronauts, and they could live on Gateway for 6 months, simulating a mission to Mars. And then they could go down to the surface of the moon, simulating that would be their Mars mission, and then come back to Gateway and spend another 6 months on Gateway before coming back to Earth. And that allows us to test out not only all the technical systems that we need in order to sustain that type of a mission without resupply missions, or do we need resupply missions? How would we be able to facilitate that? What type of radiation environment would the astronauts be exposed to, and how good is the technology we have in protecting the astronauts from radiation? And that all important psychological aspect of spending that extended period of time in such a confined quarter. So from the future going on to Mars, Gateway will perform those missions. As I mentioned, Gateway will also be able to change its orbit. So from a science perspective, we'll certainly have payloads on board Gateway, just like we have on board the International Space Station that can conduct science, gather information, and again, of course, be the port for the departure point from astronauts from Gateway down to the moon.
Great. Speaking of sort of this journey to Mars, one of the questions from Ted Lawson is, what is your view on going to Mars? Are you excited for that journey? Is it, what's your take on it?
Absolutely. It's an important step in the exploration, I think, of humankind to go to Mars, to answer some of those fundamental questions of, where did Earth come from? Was there ever life on Mars? Is there some type of microbial life on Mars? We know that we've found water. Would we be able to sustain presence on Mars? If Mars at one point did have life, what happened to Mars? Could that happen to Earth? I think there is a ton that we can learn from the exploration to Mars. We have the Perseverance rover on the way to Mars right now. That's going to land and gather samples, and those samples will be retained and held on Mars until we're able to go back to retrieve them. And so that's, again, part of this building step process in eventually taking humans to Mars. And I know that there's other companies perhaps, or other organizations that have talked about a one-way mission to Mars. That is not something that we are entertaining at all. The safety of our astronauts have the highest priority at NASA. And so this will be a building process, and we will not go to Mars until we have the technology to get us there, as well as the systems to protect us from radiation and all the life support needed. So I think you'll see some type of a stepping stone approach, maybe something similar to like a Gateway in orbit around Mars, or maybe something on the moon of Mars that we could establish before going down to the surface. So it's a very exciting time as we develop those operational concepts, and we're going to learn a lot from our missions to the moon and how best to do that most effective, most efficient, and of course the safest.
Yeah, absolutely. So Nicole, we have 2 more questions for you before we jump into our next topic. The first one is about radiation and what NASA is doing to prepare for radiation, specifically on the surface of the moon. How are we going to protect our astronauts for longer stays on the surface?
So hopefully Grant has already figured out the technology to do that, but that's one of our major limiting factors, unfortunately, as humans, is once we get outside of the Van Allen belt, the radiation is significant. And so not only having a structure that can protect us from the radiation, but also having the capability to understand and predict some of the solar events that provide high shots of radiation to the astronauts. And so they're looking at a type of a network on board the moon that's linked to systems that are monitoring solar activity, so that it would be an early warning system for the astronauts. In the event that an event happened, then we could come in from a spacewalk or a moonwalk and get back into whatever type of shelter they have designed in order to protect us from those very high radiation events.
Got it. That's pretty neat, actually. I think I saw an article about the first 4G networks going on the moon soon, maybe on Artemis 1. Maybe that's part of that system. The last question we have is from Barbara Honegger, and she's asking about the selection criteria for that first Artemis 3 female or footsteps on the moon. Is there a selection criteria? Has NASA been working on this, and can you shed any light?
Yes, so there's a very, very specific criteria. Your last name must be Mann, and it's just that basic. So no, we have 43 astronauts in the astronaut office right now, and all are eligible and very capable of conducting the moon mission. And I think there'll be the Artemis 2 mission with crew on board, and then Artemis 3 is when we'll land on the surface, obviously of the moon. And who they select in that criteria, I think it will depend on where folks are at in their career and just the timing of other missions on board the International Space Station. There will be some, I think, consideration to a crew complement to make sure that we have all the skill sets and specialties kind of required in that crew and going down to the surface of the moon. But honestly, I think anybody in the office would be capable of fulfilling that role.
A very political answer. I love it. Great. Well, thank you so much for sharing this talk with us. And we're going to move ahead with our regularly scheduled program now. And I'm going to introduce our moderator, who's going to start a panel discussion. And so Loretta Hidalgo Whitesides will be our moderator for this. She is a member of the Stanford on the Moon Advisor Committee. Loretta is a public speaker, co-creator of Yuri's Night, and an author on space exploration. Loretta actually recently launched SpaceKind, a leadership program for people who want to work in space. She's given numerous TEDx talks about space exploration and personal development. And her latest book was published in 2018. And it is The New Right Stuff, Using Space to Bring Out the Best in You. So Loretta, please go ahead and unmute yourself. The floor is yours, and introduce our panel.
Thank you, Henning. This is fantastic. Oh, sorry, I didn't realize how echoey it's going to be in here. My kids had to get flu shots today, so I'm at a friend's house in the neighborhood to try to be able to jump on for this. So thanks for bearing with me. I'm super excited to join everyone today. First, I just want to say thank you to Steve Durst and all this. I was watching like the 52 people join together today, and I was just struck by that we are a community. We have these two things in common. We have this connection to Stanford, and we have this love of space. And I thought, what a cool club, what a cool community to get to be a part of, the Stanford space community. I know when I was an undergrad, from 92 to 96. I'm an astrobiologist by training. And that's all I wanted when I was at Stanford, was to find the space people. And I ended up having to graduate and go all the way to the astronaut office in Houston to find them. But so I'm so grateful you all are here. This is fantastic. And I'm just going to jump right in. And I wanted to ping Nicole because, I just want to hear more about your, local girl makes good, story. So, from our Northern California perspective, you're from Petaluma, you did the Naval Academy, but then you got to come back and do graduate school. What is your, some favorite memories from Petaluma? Have you been back? What do you still have ties to Sonoma County? Tell us your roots.
Absolutely. So I grew up, just up the road from Stanford. And actually, when I was a little girl, I wanted to go to Stanford. It was my dream. I went and watched the United States women's soccer team play Russia at Stanford, and it was incredible. And I was hooked. And then, so it was between the Stanford and the Naval Academy when I was trying to decide on colleges. And funny enough, my coach, the coach at the Naval Academy, Karen Gabara, was like my idol growing up. I mean, posters of her on my wall as a little girl. And so when I went to the academy for a recruiting visit, I was just sold. And it had the military aspect, which I was interested in also. So I felt so fortunate then, after graduating undergrad, then to be able to come back to Stanford for my master's and get a little bit of taste of what that life would have been like, which is incredible. But my parents still live up in the North Bay area, and so we go back. Unfortunately, with COVID, we have not been back recently, but generally once or twice a year we come back. We have an opportunity to fly into Ames or every so often, and so fly right over campus, which is pretty cool. And so I love that area and just the outdoors. I miss it, and I try to take my son back and go on an adventure anytime that I can.
Oh, fantastic. Okay, and then of course we have to ask the Stanford question, which is like, what was a favorite moment of your time that you got to spend, on the farm? What do you remember?
I remember it was funny because for me, it was a little bit of a culture shock coming from the Naval Academy to Stanford. And it had been so long since I had been on the farm, just visiting as a high school kiddo. So it was funny when I came from the Naval Academy and got to Stanford. I was so excited to be there, and it was just so massive and big and so different than anything I had been exposed to at the Naval Academy. But I tell you, I think that was really important in kind of developing as a person, especially as a young woman, just to have that exposure to different types of people, different interests. And I learned so much. I grew so much as a person during that time at Stanford. And I'm always so grateful for that opportunity.
Oh, that's fantastic. And I'm we're super excited, 10 Stanford women in the astronaut program have been accepted as astronauts. And now you're the pilot of the Starliner mission. How you have your other classmates, they've been to ISS already. How do you feel about like the mission that you were selected for? What are you most excited about?
I mean, as a test pilot, it's every test pilot's dream, I think, to fly the first flight of a new, aircraft or spacecraft or anything. So I'm beyond excited for that opportunity. It's really cool. It's so interesting too, because it's really this next generation spacecraft. The intent is for it to be totally automated. Right? I mean, it is so complicated from a software perspective, everything that goes on and happens. The interesting part, though, is then integrating the human inside of that automation. That's something that we've, not struggled with, but something that's been a pull between pilot and computer, ever since the Apollo generation of spacecraft. And so I think we'll get there someday. We're not there yet. And so we still will check out. We have a manual capability, a backup capability. We'll check out, we'll turn off all the automation and check out all those systems and actually fly it old school. And so, a chance to do that is really cool, because this might be very well one of the last spacecraft that you have that capability to manually fly. And so I'm learning so much from not only the space world and operations, but really from that interface between human and machine, which is so cool. And it's really the future. Artificial intelligence, the automation of everything in our life now is where we're headed. So it's cool to be a part of that new development.
Well, it's definitely very impressive that you flew off carriers and flew combat missions, and it's amazing. And then going back to test pilot school. I mean, that's I feel like our Starliner is in good hands for piloting. It's really, I just inspiring, just everything you've done. So good job.
Thank you.
And then let's see. Oh, I was going to see. So now you're going to the International Space Station. You're talking about having to learn Russian. And what's that like? Is there a culture clash similar to when you got to Stanford, of like coming from a military background and now working in this really international environment, trying to operate in other languages?
Absolutely. And again, Grant touched on how important it is, that ability to work together as a team. So not only from people with different backgrounds, but now you're talking about international partners and speaking in different languages. So to be honest with you, learning Russian hurts my brain. I'm very more math kind of centric in my brain. And so that's been a very, very big challenge for me, but also a lot of fun. I never thought I would learn Russian. A lot of the science is really cool too. I never thought I'd be sequencing genes and dissecting animals and all these cool things that as a military test pilot, you would never have the opportunity to do. So that is cool. You get exposed to so many different things. I learned how to pull a tooth in space the other day, which is a little bit different than I guess on the ground. You push, you don't pull, you push. And we also got to learn to take our own blood, because we're guinea pigs when we're up there. A lot of those science experiments are done on us. So that was really cool to take your own blood. So that's all very exciting. I think the time on board the International Space Station is going to be so cool. I'm really excited to conduct a lot of those science experiments that are going on board now.
Now, being in the final training flow for, assigned to a mission, that's a full-time job for an astronaut. Are you still able to keep up with the Artemis mission and I know you just gave us a full presentation, but on what they're doing, and sort of keep your eye on that as, and how would you feel about, I saw that there's like 16 women currently active in the Corps, the astronaut Corps, although I guess we'll get a new class soon that might be eligible at some point, but those are pretty good odds. How do you feel about going to the moon?
I'm so excited. It's funny because sometimes I have to remember, okay, stay focused, because it's so exciting. The Artemis mission is so exciting. So every month we have a Monday morning meeting with all the astronauts, and we meet and everybody gives updates on, what's SpaceX doing, what's Boeing doing, what the Russians doing, how's station doing, and then what's going on with Artemis, which is always one of the biggest questions. It's got so much momentum behind it and so much excitement and so much support. And it's really moving along quickly. So it's so cool to see the hardware and the latest updates. And you walk into what we have is Building 9, which is where all the mock-ups are for space station and Starliner and everything. There's a human lander. There's an HLS in Building 9 right now. And so, I think everybody can't help but make sure that they follow it and kind of keep one ear listening to what's going on. Of course, in reality, I'm uber focused on Starliner and that mission. As we get closer to Starliner, that's all I'll be able to focus on. But in the meantime, gosh, it's great. I feel just like when I was a kid and you get so excited and you're thinking about the possibilities. I still feel that same way. I get so excited, so looking forward to the Starliner launch. But, I still look towards the future and say, oh my gosh, there's a possibility I could go to the moon.
Did we lose Loretta, I think? Oh, we're good. Okay.
Everything went dark for a second. It was the loss of comms. That was terrifying. We went on the dark side of the moon. So when Bob and Doug launched earlier this summer on the Dragon vehicle to International Space Station, they didn't necessarily know how long the mission was going to be, which is an interesting thing to launch into space and not know when you're coming back. Do you know how long your mission is, or there's still that same amount of uncertainty with the program? Anything could happen, and what's the range? Is it like the shortest is a week and the longest is 6 months? Do you know how long are you going to be in space?
Yes, I do not know. We're planning on 6 months. We're trained for a 6-month mission. We're trained to do all the robotics and the spacewalks and everything to support a 6-month mission. It could be 10 days though, and honestly, a lot of that depends on the other spacecraft. Is a Soyuz coming up? How many crew are on board? When's the next SpaceX launch? What about visiting vehicles? There's only so many ports on the International Space Station that we can dock to. And so, the timing of our launch will dictate, the ISS program will dictate how long they need us on board. So hopefully longer rather than shorter. But as of now, it's unknown. So we train for the 6 months, and then we take what we can get.
Oh, that's right. Yeah, I saw the footage of you training in the NBL, the Neutral Buoyancy Lab. I'll try to acronym things. Training for a space flight. Yeah, that's pretty exciting. While you're in space, you might get to do a spacewalk.
I hope so. That would be awesome. Training in the Neutral Buoyancy Lab is part of the coolest things that we do. Training, because they put you in the spacesuit, which is just like a regular spacesuit, and then they pressurize you to 4.3 psi-D. And so you're blown up like this balloon. And then they put you in the water with a life-size mock-up of the International Space Station. And then they use the weights and foam to weigh you out to try to simulate microgravity. And there's a team of divers that are transferring tools. So you'll carry a plastic drill essentially, and then you'll put it up to a bolt if you're changing out a box, and then they'll swap it out with a real drill that will actually be heavy. Then you'll drive the bolts and then swap it back with them. So those guys are working their butts off. But everybody says that's some of the best training that you can have for a spacewalk. And some of my friends that recently did a spacewalk said, they were out there doing the spacewalk, and then for a second they forgot. They thought, oh, I'm in the Neutral Buoyancy Lab. Where's the diver? And then they're like, oh no, I'm in space. There's no diver around. But I was in we call it the pool. So I was in the pool the other day doing the spacewalk training, and I looked over, and there were people in the XEMU, which is the new spacesuit that we'll walk on the moon with, and they're practicing planting the flag. And so I kind of stopped and just watched for a little bit, because it was just it just brings it all home. Like, it's so real now that we're actually training for these events and these missions, and they're figuring out what tools do we need? How are we going to do that? Is this spacesuit going to be capable? So that was really cool to see in the NBL.
Oh, that's great. All right, so we're getting our 15-minute warning here. I'm going to take a question from the audience. So, Carl asks, what are your views on SpaceX?
Sorry, you went silent there for a second.
Sorry, Carl asks, what are your views on SpaceX?
Oh, SpaceX is incredible. I was, fortunately, I had the chance to be out at Kennedy Space Center when Doug and Bob launched on the Demo 2 mission. And one of my classmates, Victor Glover, is launching on the Crew 1 mission. And so they're launching in the middle, I think middle of November, middle of November is their launch date now. So it's just an incredible company to see the technology that they're able to develop and how rapid that they're able to move through. And, Doug and Bob had a very successful mission, and Crew Dragon performed exceptionally. And so I think it's a great partnership with NASA, with SpaceX, with Boeing. It's an interesting business plan where we've actually contracted the whole transportation. And so, SpaceX ran that mission control and everything, conducted the whole mission. And it just really is great to see that capability. It's going to open up the world in ways that we've only just thought about in the past to the commercial industry. And so I think in the very near future, you'll see astronauts in space that are commercial astronauts, and you'll see maybe other mini type of space stations or other ventures into space. And that's going to just allow more people to go to space, whether it be space tourism or scientists or a journalist or an artist, and somebody that's going to be able to capture, just the amazingness of being in space and of our planet, and communicate that back to people on Earth in a way that, a Marine pilot cannot do. So I think it's going to be incredible for just inspiring that young generation and really uniting the world in this effort in low Earth orbit. And so it's a really exciting time as we turn over low Earth orbit to commercial companies.
Great. And then from Joel, we have, how do you make the work-life balance work with the busy schedule of an astronaut?
Joel, how do you make it work? I mean, it's tough, I tell you, but I think it's tough for everybody, right? If you have a mom and dad and you're both working and you have a kiddo, it's that constant work-life balance that I haven't figured out. So if you have figured it out, let me know. But sometimes it's important that I focus on Starliner in my training, and so that 6 months prior to launch will probably be very focused on Starliner. But then when I get back from space, I'll have some time to kind of decompress and refocus on my family. So I kind of feel like you don't find a balance and strike it and then boom, you made it for life. I feel like this is something that's always continually being worked on and continually needs to change based on the demands of what mission I'm training for or what's going on at work, and also based on the demands of my family, at home, and what's going on with my husband and what's my kiddo up to. And so, I think it's a constant working act that I think that everybody kind of deals with.
That's great. So Phoebe wants to know suggestions for how to make her astronaut application stand out in the pool. We need to get Stanford astronaut number 11 in there. So.
Yes, we do. Yeah, we're selecting a class coming up in 21 will be the next class. And typically we've selected astronauts every 4 years, but there's no set guidance. It just depends on kind of the needs of the office. So I wished I knew some super secret recipe to becoming an astronaut. And everybody, there's not one specific path either. Everybody has a different path. And some people started on one path and then went off on a different path. But the one thing that I found in common with all the astronauts that I know is whatever they did in life, they followed their passions in life, and they were great at whatever their job was, whatever career they had. And if they didn't get selected to be an astronaut, they'd be happy fulfilling their life dream in whatever career that they had. It just so happens that by doing that, then all those experiences you have in life and everything that you've committed to this career now opens this door, this other opportunity. And you can maybe take that path over there. So I would say, if being an astronaut is something that you're interested in, don't make decisions based solely on, I think this will be better to become an astronaut, because there's no recipe out there. It's really finding that success in your life, and then being the person that has not only the emotional what'd you call it, emotional maturity, right? The ability to work with people, to work on a team, take care of yourself, to do all that is just as important as your technical background.
Have you gotten to sit in on any astronaut interviews yet?
No, I have not. And that they haven't started the interview process for this upcoming class. But since I'm training for a flight, I won't get a chance to sit on any of them.
That'll be an interesting moment. Okay, and then the gimme question. Have you seen any episodes of Netflix series Away with Hilary Swank and the Mars mission?
I have, yes, but I'm only on like episode 5, so don't ruin it for me. Don't tell me what happens. But it's incredible. I know a lot of astronauts consulted with them during the making of that film to try to make it more realistic. You know, of course, there's the Hollywood twist and drama on everything, but you know, from like the way they're floating and what they're doing and some of the, you know, issues you have or potential issues you could have. I think it's pretty entertaining, so I'm enjoying it.
That's great. All right, Henning, should I bring in Grant and Steve, or should we keep questions for Nicole?
It's up to you. You're in charge. You know, Grant, I'm sure, has some very interesting takes, and we can hear his perspective as well. And Steve, of course,
I have a question for Grant.
Yeah, that's. I want to see some panel interaction too. Go for it, Nicole.
Okay, so we had the question, Grant, about radiation, and is that something that you guys are working on? And just wondering if you're able to share any of your ideas concerning radiation protection, whether it be in cislunar space or on the moon.
Sure. Can you hear me?
Yes.
Yeah. So yeah, we do work in that area, and there's really 2 types of radiation you have to talk about. One is what's called SPEs, or solar proton events, which are sort of the outbursts from the moon. That's what Nicole talked about, trying to find a prediction capability. We were to some degree rolling the dice with every Apollo mission, and got it pretty lucky. In fact, if you ever get a chance, there's a great graph of solar proton events that happened, and the Apollo missions happened to be right when they weren't there, which is really unfortunate. But the other type of radiation is called GREs, is galactic radiation. And those are extremely high energy particles. Frankly, there is no practical way to shield from them right now. So really, and in fact, maybe counterintuitively, unless you're a Stanford engineer in material science, and I know that there's at least one of them here, is that when you put some aluminum between you and some of these radiation particles, you actually get more radiation because there's secondary radiation effects that comes in and knocks out a whole bunch of stuff and sprays it at you. So there are 2 different things we're working on, of course. One of them is in the short-term events. The good shields are water, pretty much anything with low molecular weight things, and hydrogen, of course, being the lower molecular weight. So water, paraffins, so some blocks of paraffins, and then there's other versions of that. There's an Israeli company that actually makes a suit that has these little hexagonal little things out of it that you can wrap around yourself. And the good thing is it also somewhat directs your shielding, but that comes into another problem, which is that a real misunderstanding about radiation is very often people say, well, just put something between me and the sun, say. But in reality, radiation comes out from the sun as sort of boiling in this. If you remember the old Star Trek episodes, and all these have this sort of cloud kind of going over the spacecraft and sitting on it, it's a little bit more like that. When a radiation event hits you from solar proton, it comes from all directions. So there's not like a way to put just shielding in one place. And so we've really done a lot of trades in our 27 years and come down to you do need some sort of a personal suit, because putting a radiation shield on the whole spacecraft, for one thing, you're not going to be able to do galactic radiation anyway. And so it's those solar proton events that can last anywhere from 24 hours to about 3.5 days or 4 days even. There was a great expert out of Boeing called Bill Atwell. Unfortunately, he passed last year. That was one of the best. He was the best person in the world. Everybody who has a PhD in space radiation went through. Bill was on their advisory board. Let's put it that way. Anyway, so that's the other thing. So we have narrowed it down to putting localized and then what we call radiation shelters. Now, Nicole may absolutely grimace when you say you might have to spend 4 days in something even smaller than the spacecraft while you're waiting for a radiation event to go by. But that's probably the best way to do it for long durations missions to Mars.
And then Grant, I think you had a question for Nicole too.
One of them, Nicole, you were talking about spacecraft automation, and we run on that a lot. And in fact, one of the things that I think I actually coined the phrase is that when we go to Mars, it's no longer Houston, we have a problem. It's Houston, we had a problem 15 minutes ago. And so it really changed the dynamics. Do you really have a mission control? You now have a mission monitoring at home. You can't be a control. I know of no astronaut that's going to wait for 15 minutes in emergency and wait, or actually 30 minutes for a round trip to say, hey, NASA, what should I do from Houston? So that's a whole nother thing. But one of the things that the Apollo had, and of course they had a lot of smart people doing that, is they have the proceed button. In other words, the computer, they would initiate the next sequence, or whether it was a burn for TLI or whatever else, and the computer would come up and say proceed, and the astronaut actually had to hit the button. Does CST-100 have that same idea?
We do, but we only have it about 4 times throughout the mission. So the entire mission is automated in essentially a dumb automation, just a series of commands that run, and we'll pull data and make cues on that. And so some of the critical times that we have, especially when we approach the space station, so before we enter the keep out sphere or the approach ellipsoid, we issue an ATP, which is authority to proceed. And so that's a command that we issue in order to keep the automation moving along. In fact, we found during a lot of the simulations and testing that there are perhaps some other areas where we don't want the automation just to go, whether it be based on a trigger of some data or based on timing. We want to hey, stop and proceed on our command. So we also have what's called a trigger next, is our ability to control that automation and move it forward. And so that's been very interesting. We have a similar case when we undock, but we also do have the ability just to stop the automation. The interesting thing is, though, getting the automation going again and making sure when it starts, all these automated scripts are synced up and running properly, and that you don't get sideways in some way that you didn't mean to. And so I know the software guys are very smart, intelligent folks, and I'm sure the human in the loop problem is an exponential issue for them. If there was no humans on board, they'd be happy. It'd be a cargo vehicle, but that's the challenge, and is interfacing with the automation. Sometimes we joke, there's 3 of us on our crew, and sometimes we joke that the automation is this 4th crew member that's flipping switches and doing things, and sometimes you're not sure what they're doing. And if it's, especially an off-nominal situation, is the fault response that's taking actions and might be opening a valve at a certain pressure, and it just catches you off guard. And so that's an interesting type of human-computer interface that we struggle through, that I know, they struggle through, on the Apollo program and shuttle, but this is definitely the next level of automation. The Orion spacecraft now, that's even one step above in operations. So we still have procedures that we run as crew. They're all electronic now, so we'll fly with a tablet, and all the procedures are a tablet. But we're still pushing buttons and still sending commands via switches and via touch buttons on the side of a display. Orion now has electronic procedures. So the spacecraft runs the procedure for you. And then you just acknowledge, yes, that looks right. Yes, that looks right. So it's, hey, make sure this temperature of this sensor is between this range. It will then bring up that temperature, show you the range, and say, yes, it's good. And you acknowledge it and move through. And so that is interesting. It kind of makes you feel a little bit like, why are they really asking me to acknowledge? They're just trying to make me feel good by having me acknowledge, because I'm not doing anything. But you're still able to intervene in the automation when you need to. But that's certainly the way we're going. And I think it's important when we go on that mission to Mars, and even on the missions to the moon, no longer, I think the far future idea is no longer are we going to have to spend 4 years training an astronaut how to fly this spacecraft and how to deal with contingencies. Hopefully it'll be much more automated and taken care of, and now the astronauts can focus on doing the science and doing the exploration and building, the habitats on the moon or on Mars that we need. So it's definitely a paradigm shift that we're looking towards.
Oh, we're definitely going to have to talk about that, but we could use up another 3 hours sometime. But I will say this, I got a call when, very unfortunately, we lost the 2 737 MAXs. My brother, who invests in airlines, called up me and aircrafts, called up to me and said, what does this do? And I said, well, it'll delay autonomous cars for another 10 years. And he said, what does that have to do with the 737 MAX? And I said, the first 3 autonomous cars to all turn left off the Brooklyn Bridge and run into the river. That's the problem, is if you have too much automation and it can override the humans, that's a really bad thing. And what you were saying there, Nicole, is you still have to acknowledge things. And you always hear the not apocryphal stories about people falling asleep in their Teslas as they're riding down the road. Automation, especially with a lot of other people around, is really terrible. Frankly, it's until we got quantum computing, I don't think it's ever going to be safe, frankly, myself. But that's for a whole nother topic sometime.
Well, Grant, why don't you, how much can you tell us about how many of the current, Crew, spacecraft ISS, Artemis spacecraft, and Orion space vehicles do you have life support systems on?
We have parts on everything. On the first Orion vehicle that flew, we had 230 different assemblies of some type or another. The second one that's now sitting on the pad, we only have about 112 or so. Lockheed was bringing a lot more stuff in-house. That's one of those things, once you get something developed. Frankly, yeah, and I very specifically didn't give you any pitch on Paragon, but we have been involved in every single human spacecraft design since 1996. So that includes all the things precursor to Orion. And we actually did the environmental control structure, architecture for both CST-100 and the Dragon. So those both are our architectures. Elon decided after he got it all that he said, okay, great, I'm going to go do it myself, and built most of it himself. Just between us, I've had to send him a few legal documents on saying that it's violating his NDA, and he's had to fix a few things. Orion, actually, Paragon, for the first 4 years, the Orion program, we actually had the whole spacecraft schematic, just not just the Eclipse, but the whole spacecraft, everything, avionics, power, everything else. Because one thing about environmental control is we touch everybody, because it's not only about keeping the humans alive, but we also keep the avionics at the right temperature, we keep the batteries at the right temperature, we keep the propulsion system at the right temperature. So we have to know what's going on all over the spacecraft. So we tend to do full up spacecraft schematics. And anyway, so that we haven't done anything on the foreign side. We actually also were supposed to build the radiators for Orion, and then NASA decided to move the service module over to the European side, so we lost that to the Italian company. Alana Spazio, I've got some great friends there, so every time I come in, I make them buy me a beer because they took that from me. And then, and of course, and now the HLS, we're on Dianetics team, and we're doing the environmental control, including the interfaces with the spacesuit. And then there's another program that's also related to government and stuff that I'm not allowed to talk about. That is also, we're doing the environmental control system completely for that one also.
Great. Well, we've gotten the time signal from Henning, so we're going to turn it back over to Steve for our award ceremony and final words. But thank you, Grant, and thank you, Nicole. This is so much fun to geek out and play space with our Stanford friends. Thanks.
Thank you very much. It was fun.
Yes, thank you.
Well, hello, Henning. Can you hear me? Am I audible?
Yes, loud and clear.
Well, thank you so much, Nicole and Grant and Loretta. I hope you're still standing by if there are any comments on a couple of observations that I can contribute, perhaps a different perspective than the high level and dynamic and exciting advanced astronautics considerations that we heard discussed by Nicole and Grant. Really exciting. The work that I've been involved in out in Hawaii with the International Lunar Observatory Association seeks to put a telescope on the moon, which has major implications for Hawaii itself, still a great center for astronomy in the world, and a lot of controversy about how to continue developing Hawaii astronomy into the 21st century. Our answer is to not necessarily put more instruments on already crowded and somewhat controversial Mauna Kea, but put them on the moon for many reasons. And we do have a contract that assures that 2 of our precursor instruments will fly to the moon, or they're scheduled to on a SpaceX launch of of one of the NASA awarded CLIPS programs run by Intuitive Machines. The first thing that we intend to look at, and that was a hard question, first light, we'll be trying to get the first image of the Milky Way galaxy ever from the moon. And it will be distinguished not by being an image of the Milky Way galaxy, there are many, but the first one from the moon, an engineering accomplishment, symbolic of our first big step out into the galaxy, the step to the moon. So we think also that that first image of the galaxy from the moon may have a similar effect as the first image of Earth from the moon. When we went to the moon in the 20th century and looked back at the home planet Earth and saw that Earthrise image for the first time, we all know the profound effect it had on all 4 million Earthlings at that time. The ecological, environmental awareness and consciousness that emerged into the environmental movement that so influenced the last 50 years. When we go back in the 21st century and look back not only at home, back at Earth, but out towards our future, to the Milky Way galaxy, that should, it could have the same inspiring directional effect that the Earthrise image had. Another consideration that when we began our editorial work at Space Age Publishing Company, and we intend to publish and broadcast from the moon, building off on the communications capability that the Lunar Telescope will provide, that at Space Age 4 years ago during the 2016 presidential campaign, we began, since one of the candidates was female, we began advocated pretty much by ourselves at that time for first woman on the moon. And it's had just partly because of some of the work that we did, that reality has moved along. And it's been really amazing and exciting to see this new program, barely over a year old, the Artemis program, to put the first woman and the next man. Thank you, Nicole. It could be you both times on the moon. This Artemis program, I liken it to watching a tree grow, sinking roots, growing high, sprouting out branches and leaves all the way to the moon. And I think, as Nicole mentioned, it's going to be tremendously exciting to a country and a planet that needs every bit of energy and enthusiasm and encouragement it can get. And certainly looking forward to 2021 and pushing on to the moon and beyond. So those are some of the activities and perspectives I wanted to share with you all, and with Nicole, with you, and Grant and Loretta Henning. And I don't know if there are any comments on what I've just mentioned. Loretta, if you see any or have any yourself, but I wanted to thank you in any case on a great presentation, Nicole, and spirited dialogue that you catalyzed, Loretta. So if there are any questions, perhaps we have time for one or two more, or any other comments.
Great. Well, let's go back to the one question that I had to skip over for time, which was, what is the most rewarding aspect of working at NASA for Nicole?
You're gonna make me just pick one? I mean,
I know. Yeah,
that's tough. There's a lot to it. I really think getting the opportunity to, participate and interact with folks like you, interact with people in the community, whether it be school kids, or other organizations, is one of the most rewarding things they're not, specifically a part of the job, but you can really see people get so excited when we do a talk about the missions that we're doing, and especially in young kids, you can just see their eyes light up and their brains just start turning on, and they have ideas maybe on what we could do next or how we could go here. And I think that is personally very exciting and very rewarding to know that, maybe we're able to influence just one or two or a handful of kids, and these bright minds might be the ones that take us to Mars, or might be the ones going to Mars, and they're going to come up with this incredible idea of how to protect us, from the radiation, or how we're going to make a more fuel efficient spacecraft. So that's one aspect of the job that I didn't realize was going to be so exciting and so rewarding when I came into it.
Have you ever spoken at any schools that you went to, like in Sonoma County or back at Stanford, or what is some other outreach that you've done in person pre-COVID that was really a hoot for you? Really enjoyed.
Right now, it's more virtual things these days. But yeah, I've had an opportunity with obviously with the military, we do quite a bit of outreach, and then with schools. Specifically, we used to do quite a few events where we would travel and speak to an auditorium of school kids, and maybe visit 3 or 4 schools that day while we were out and about. So that's always been a lot of fun.
Grant just posted a link to his YouTube talk for people who want to know more about ECLSS, which is Environmental Control and Life Support Systems, to decode our acronym language.
I will definitely check that out.
That's great. I feel like we've exhausted you. We've been talking, put you on the stand here for an hour, but we're just so proud and excited of everything you're doing. And I'm trying to search my brain for any other important fun things we can ask you. What didn't we ask you that we should have asked you? What would you want to tell the Stanford gang about?
Maybe if there's anybody online, we talked a little bit, about, becoming an astronaut and the different paths. Maybe just a little bit if there's folks out there that are interested, kind of just the way it works a little bit more is that, it's a government job. And so the announcement comes out on a USA jobs.gov, and you just apply via website, believe it or not, just like every government job. And then you, fill out an application, you submit a paper, and of course you have references that you submit, and then you send that application in, and then you hear nothing for a long time. You just kind of wait, and they will start, calling references and getting ideas, and then they will whittle that down to, not sure what the numbers are these days, around 100 or so folks that will come down for an interview. That's usually about a week long, which consists of formal interviews, a lot of medical tests, some psychological tests, some other kind of group tests. You don't really know what they're testing you on or what they're looking for, but a lot of that is how you're working together in a team, how you're doing with problem solving. But overall, it's a lot of fun. You get to experience a lot of the cool training that we do at NASA just on that week-long visit. There's also some social events that you'll attend. And then it's about, a couple more months, they'll whittle that down to about 50 people. If you make that cut, you come back for another week of interviews, more medical exams, more tests and evaluations. And then eventually they'll pick the class and give you a phone call if you made the selection to come down to be an astronaut. So it's a long kind of a drawn out process with not a lot of feedback. So don't get frustrated by that or anything. Just take it every step along the way. But certainly if you're interested in applying, never disqualify yourself. Always put your name in the hat, and you never know what exactly they're looking for. So just go down and be yourself.
Could I ask a follow-up question to that? Are there
Sure.
any things that automatically disqualify you with regards to like height, or whether you're like eyesight or something like that?
I don't think there's any height and weight requirements. There are definitely a long list of medical requirements based on long duration mission, but I'm not sure on the site. So like I had horrible eyesight and I had PRK actually while I was at Stanford before I went off to flight school. And there's definitely plenty of people that have glasses or have had laser eye surgery. So I don't know that would be a big factor. But that's a funny thing is too, even if you think you have something that might be medically disqualifying, submit your application anyways, and they'll go through the tests. And a lot of times if they find something, it's not always a black and white answer. They will try their hardest to get you, passing through the boards. And just because you have one thing, it depends on how it presents itself and what kind of mitigation they can do for your mission. So I would definitely put your name in the hat and let the docs tell you no. Don't tell yourself no.
And if you're applying, Sarli, is it purely like from like a purely scientific background? Let's say not having like a Marine or pilot school background. Do you need to have like a research proposal that you kind of submit along with your application, like for like anything like that?
No, once you become an astronaut, you kind of no longer do your previous job. So some people can stay involved a little bit, but the time commitment is pretty significant. And they will kind of pull on your expertise, whatever your background is. For example, if you're a medical doctor, they pull you in on medical type of programs that we're working on. But you really, you have to give up all of your research and your science and all your kind of previous jobs when you come in. And so they don't look at that. We have plenty of folks that are pure scientists that have, no aviation background, that have no military background or anything. So that's certainly not a prerequisite. In fact, about half of the astronaut office right now is either active military, retired military. So half is not, that big of a number compared to, the Apollo days. And only a quarter of the office are pilots. And so that's certainly not a requirement. I think they might have an advanced degree as a requirement these days. I know they were updating that. But I also do look at kind of your the whole person, so make sure you bring out in the application, if you can, or in your discussions in an interview, anything that you've done working with teams, working with international partners, working with folks other than of your same background, just shows that you're diverse and able to work in a group. And if you have any examples of things that you've done in an expeditionary environment, type of a camping thing or a research trip that you did, or you were in the Antarctic or anything like that, just does help to show that you're able to, work with a group of people and outside of an office environment and maybe under some conditions that aren't so comfortable. And if you also have, any background in scuba diving or flying airplanes, even if it's a little bit, those are things that we do every week on the job. And so it just shows your diverse background.
Thank you.
Sure.
Yeah, I just posted it, but I know when I looked at applying to be an astronaut in 1983, my eyes were a disqualification. And at that time, they wouldn't allow LASIK. So in 1983, LASIK was fairly new and stuff like that. And one of the things that I know Nicole's been versed on is your intraocular pressure, your eye pressure goes up in space, having to do with fluid shift and everything else. And they were a little bit worried about what that would do if you had LASIK, the old, alien thing, your eyeball would burst if you were exposed to low pressure. But times change and medical technology changed. And I had a question come up about that, about the radiation too. I concentrate on the shielding. The other thing is changing the human a little bit. There's a lot of drug research going on radiation mitigation drugs, and also genetic profiling and genetic issues. There's a doctor called Dr. Jonathan Clark. He actually lost his wife on Columbia in 2003, Laurel Clark, but he has been very much into looking at medical ways of mitigating radiation, which is a whole nother field that would take a long time to talk about.
Nicole, I had one other question, which is, we had Tammy Jernigan on at the beginning of this event, another Stanford woman astronaut. Have you had a chance to meet any of the retired pantheon of women astronauts? Do they come back to Houston? Do you guys get to interact at all?
They do. It's really cool. We have a couple opportunities. We have an astronaut reunion every couple years, and a lot of the former astronauts will come back. We have a chance we update them on, currently what's going on in the office with our missions, and then we just get to hear their stories, which is sometimes the best part about it. And sometimes it's a story you've heard before, but to hear it from the actual, astronaut is, NASA still does from a medical perspective. The astronauts come back every year for their annual physical. And so a lot of times we'll just do like a coffee call. So they're here for all their medical, and they'll just come in the office. We just get to sit down and have coffee with them, just ask them questions, again, hear their stories, or get their advice on some of the, future missions that are coming up. So it's always a special moment when we get a chance to talk to one of the formers.
Fantastic. Sounds of fun. Okay, well, I've gotten word that Steve wants to have the floor again. So, Steve Durst.
Thank you, Loretta, and thank you so much, Nicole, for your very, very inspiring, informative, and dynamic presentation, and wishing you all the best. And Grant, hope you make that equipment perfect for Nicole and her astronaut companions to safeguard them. I can't get a slide up that we have that show all 10 Stanford women astronauts. I had a little technical problem, but that poster is hanging in the physics department lobby with 9 other Stanford women astronaut posters. Nicole, there's a very special one that we're making just for you as well, and I apologize for not putting it up earlier, but next time you have a chance to return. And there, by the way, thank you very much, Elisa, is the poster of all 10 Stanford women astronauts.
Oh, wow. Sally Ride, Mae Jamieson, Ellen Ochoa, Tammy Jernigan, Susan
Helms.
Susan Helms, thank you. It blanked. Eileen Collins, Kate Rubins, scroll down.
Barbara Morgan.
And who are the last 2? Oh, that's Jessica, isn't it?
That's right.
And then I just don't know the one on the bottom right. Oh,
Who's
that lady? Oh, Nicole, fabulous. We got them all.
Yeah.
Collect all 10.
And that's great. It was Kate that just launched on Wednesday up to the space station. So it was really cool to see her go back up again.
So perhaps the odds are reasonable that the first woman on the moon, just like the first American woman in space, will be from Stanford. And to move that along, the Stanford on the Moon Endowment Fund, established with the help of the Alumni Association 5 years ago during my 50th class reunion, makes distributions and awards every year, modestly to start with, but it will help to make the Center for Stanford on the Moon a reality. And this year, is Denise Elstead or Fred Tomlin still on the call?
I'm on the call, Steve. I don't know if it's me.
Hi. Oh, great picture. Great, Fred. If you would like to join me in making these 2 awards to the Stanford Student Observatory.
Yeah, no, thank you. Thank you to Henning for hosting this wonderful event. This has been really eye-opening, and just my jaw is always on the floor at the Stanford on the Moon annual event. So thank you, Nicole, Grant, and Loretta as well for speaking. So yeah, we're really happy this year to be awarding 2 organizations on campus with awards from the Stanford on the Moon Endowment Fund. The first one is the Stanford Student Observatory, and Bruce McIntosh has joined the call today, and he works closely with the observatory and all telescopes on campus, or off campus, I suppose. And we're really thrilled to be working with that. And then the second is the Stanford Astronomical Society, which is a student organization. Professor Roger Romani has been previously associated with them, and they have a new faculty director now, but yeah, they're both really great student organizations on campus that further space research, and yeah, and we're just really happy that to have Stanford on the Moon, the Alumni Club, participating in this way on campus. So thank you.
Thank you, Fred, and that's a wonderful backdrop there. Favorite topics, the galaxy, moon, and Stanford. Pretty strong threesome there. Well, I'd like to thank everybody, John Stephen at NASA Astronaut Office for helping to liaison and make arrangements for Nicole's presentation and participation. Our speakers, all the members of the advisory committee, and I think there've been 9 or 10 that were at this meeting. And I don't know, I think we had well over 50 participants at one point or another. And looking forward, just tending to club business a bit, station keeping as it were, we are formally looking for an executive director to institutionalize a position at Stanford on the Moon to carry on into the decades ahead, and it will be a long journey before we see a Center for Stanford on the Moon. There probably will need to be a Center for Stanford in Antarctica, the 7th continent, before we see one on the 8th continent. But we will, sometime this century, realize that, and an executive director would give us continuity. So anybody interested in working with students and faculty in various Stanford departments to advance the mission of Stanford on the Moon, help build the foundation for advancing lunar research and interests at Stanford, which are now finally, from the Artemis program, it's still not widely known, nor has it widely entered Stanford research and studies, but it is coming, and that would be one of the main roles of the executive director. So please get in touch with us. It would be a volunteer position to help to coordinate annual events at Stanford on the Moon and work with Stanford students, faculty, and administration. Our email address, which we should put on screen, but it should be available, Stanford on the Moon at spaceagepub.com. Stanford on the Moon at spaceagepub.com. So I think that's it. I think it's very commendable for everybody's efforts in these times. With the challenges, anything that's accomplished is that much more influential and memorable and effective. And I don't have anything more to say other than we'll be back. Our class reunion, like all of the 5-year reunion cycles, have been pushed back till 2021. So we will have another Stanford on the Moon alumni conference this time next year. And I wish you all safe travels, to be active as much as you can, and of course careful, take good care. And thank you all very much. And as we say in Hawaii, aloha. Thank you.
Wow. Thank you, Steve. Great work. Thanks for coming, everyone.
Thank you. Thanks, everybody. Thanks, Loretta. Good to see you.
Thank you, everybody.
Thank you, Nicole. Taking time.
Thank you.
Good luck. We'll be pulling for you. I'm super excited.
Thanks.
And we got a fan on board, or someone we know, a friend on board.
There you go. Thank you, everyone.
I wanted to thank the Stanford Physics Department, too, for giving us a home these past few years. Thanks so much. And Roger Romani and Bruce McIntosh as recipients of the award. I'm sorry we didn't have time to give you a video shot or a chance to speak, but we'll follow up on this into the future. Thank you.
I could say it's beer o'clock at Paragon. I have to get onto that. That's one of my duties as president and CEO. So we have beer o'clock 4:30 every Friday. That's one of the benefits of working at Paragon.
Woohoo!
Hi, Roger.
Bye.
I saw Roger. Hi, Roger.
See ya. Thanks, Grant. Bye, all.
Bye, everyone. Thank you.